Hi there, it's Mrs. Trombley. Today we are going to talk all about the distributive property. And learning about this is going to help us simplify expressions because, as I said before, an expression containing parentheses is not in simplest form. So we've been simplifying expressions by combining like terms because we learned an expression is not in simplest form if it has like terms in it. An expression is also not in simplest form if it has parentheses. So what I would like for you to do today is to rewrite expressions without parentheses, but we have to keep the value the same. And the distributive property is what helps us do that. So we have kind of a nice little visual model here to help you understand why it works and how it works so that we're not just memorizing things. There's too many things to memorize in math. If you just spend all your time memorizing, then we wouldn't really understand a whole lot. And I want you to understand. So take a look. Our objective is to write two different expressions for each picture, and one of the expressions should contain parentheses and one should not. So let's start with the one without the parentheses because I think that's one we're familiar with. Just picture these as algebra blocks, and let's say that these are the yellow rectangles. And these are the little green blocks that were each worth 1. If you were going to write an expression for this picture, we would say that we have 1, 2, 3, 4 y's, plus we have 1, 2, 3, 4 green blocks, right? 4y plus 4. We can't say that we have 8 of anything now because we don't. We have 4 of those and 4 of those. Try it with this next one. Let's just assume these are all y's. And I would have 1, 2, 3, 4, 5, 6 y's, plus 3, 6, 9 green blocks. And for our last example here, we have 1, 2, 3, 4, 5, 6 y's again, but this time we have 2, 4 green blocks. So right now we have one expression written for each picture. Now I want us to write a second expression that represents the same exact picture, so it'll have the same value, but I want this one to contain parentheses. So we're going to kind of look at this in terms of groups to help us write this. And I'm hoping that you're seeing I kind of have separated this to make it 4 groups of the same thing. Each group has to contain the same amount. So right now, I could say that I have y plus 1 4 times, right? To express that, I can say y plus 1, and I don't want to write times 4 at the end because then I'd only be multiplying the 1 and the 4. I want to have 4 y's and 4 1's. So to do that, I'm going to use parentheses and rewrite it like this. So this expression right here also represents this picture because it's saying that you have y plus 1 4 times. Let's try to do that same thing with the next picture here. We can see that we have 3 groups of the same thing. So in each group, we have 2 y's plus 3 blocks. And how many times do we have that? We have that entire amount 3 times. So this expression right here also represents that picture. That makes those two expressions equivalent. The last one here, I see that we have 2 equal groups. And it's 2 equal groups of what? Well, in each group, I have 3 y's and 2 blocks. And how many times do I have 3y plus 2? I have that entire amount twice. Okay, so here's where the distributive property comes in. What I want you to be able to do today is get rid of parentheses without changing the value, right? So take a look at this one here. And I want you to ask yourself, how can I move from this expression, to the one with parentheses to the one without? What does it look like it's happening here? And I'm going to draw in some little arrows to maybe help us along here. I'm hoping that you're seeing that 4 times y is 4y, and I need this addition sign to separate the terms or they fight. And 4 times 1 is 4, right? Now let's see if that same process works here. If you take 3 times 2y, so you're saying 2y, 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 that means I have 6y, separating that with an addition sign, and 3 times 3 is 9. Yeah? Give it one more shot and see if it works here. 3rd time's a charm. 2 times 3y. So that means you have 3y and another 3y, which makes 6y. Plus 2 times 2 is 4. Yes. So this is the distributive property. All you're doing is taking the number on the outside of the parentheses and you're multiplying it by each term on the inside. And that's what these little blanks are all about down here. It says to rewrite an expression containing parentheses, we're going to multiply, that's your first blank. Multiply, sorry. I don't have my little whiteout pen with me here, so it's alright, it says multiply. So you want to multiply the number next to the parentheses by all of the terms inside the parentheses. And by doing that, you're allowing to remove parentheses without changing the value, because don't both of those expressions represent the same picture? So they're equivalent expressions, but one contains parentheses and one doesn't. When you're simplifying expressions today, you can't have parentheses in it. And that's all you'll have to do to remove it. So let's try some of that. Turn your page. Alright, so I have steps written out for you, of course, so you can refer back to them. And we'll follow these steps for each problem that we do. Step 1, of course, change all subtraction to addition by adding the opposite. It's been ingrained. I know you probably don't even need me to write that step anymore, but I'll keep doing it. Step number 2 is remove the parentheses using the distributive property. So that's where we're going to take the number on the outside and multiply it by everything on the inside. And there's a little note here. Only the number next to the parentheses gets distributed. Just rewrite the rest. So the number next to the parentheses is the one that you're multiplying. If you have an addition sign between something and it's not right next to it, you're just going to end up dropping it down. And if that doesn't make sense yet, I know it will by the last example. Step number 3, combine like terms. Now we know in math that order of operations does matter, right? So when it says to get rid of parentheses first and then combine like terms, you have to get rid of parentheses first and then combine like terms. You can't start combining like terms right off the bat and then try to get rid of parentheses. You'll end up getting an incorrect answer. Alright, so our job is to simplify each algebraic expression. Again, we're not solving it, we're just making it simplified. And expressions are not in simplest form if they contain like terms and parentheses. So in looking at this, step 1, let's change our subtraction to addition by adding the opposite. Use a different color. And there we go. Step 2 says use the distributive property to remove parentheses. So this 5 is right next to the parentheses. That's the number I'm going to distribute. I like putting these little arrows because it helps me remember to distribute the 5 to everything inside. A lot of people make the mistake of just saying 5x and then they write plus -8 and forget to distribute the 5 to the -8. I think for me, having 2 children helps me to remember that if I am going to give 5 cookies to Ethan, I need to give 5 cookies to Ellie, or someone is going to fight. And I don't like fights, especially in the kitchen. I have a hard tile floor, and somebody gets knocked off the chair. It's no fun. So if you're going to distribute the number on the outside, you need to distribute it to each term on the inside so no one feels left out. 5 times x is 5x. I need to keep my addition sign separating the unlike terms here. And 5 times -8 is -40. Now this right here is what I was talking about in the hint, where I said only multiply the number next to the parentheses. 4x isn't touching the parentheses. It's separated from it by an addition sign. That's where you just drop it down. So there, we're on step 3 now. Step 3 says combine any like terms that you see. Because we're still not simplest form. I know parentheses are gone, but I have a 5x here and a 4x here. And we know that we can combine like terms by adding their coefficient. So you have 5x's and another 4x's. That means we have 9x, and we still have this plus -40 left. Those are not like terms, so this means we're done. We can't combine those any further. All set. All right, take a look at the next one. Step 1, keep, change. Step 2, get rid of any parentheses by distributing the number next to the parentheses to everything inside. This 4 is right next to the parentheses. I'm going to distribute the 4 to everything inside. So 4 times 3g is 12g. Bring down your addition sign, and 4 times 1 is 4. This -5 is just being added on at the end, so I'm just going to drop it down. Alright, we still have some like terms to combine. I see I have 12 G's and another negative 5 G's. So altogether, we have 7 G's. All right. And we still have this this positive 4 that's being added. So we have 7G plus 4. We can't now say that we have 11 G's. I wish we could. We could go shopping. It would be a great time. But we don't. We have 7 G's and just 4. So that means you're done because those are not like terms. This has a G, that has nothing. Next one, keep, change, change is still our first step. Now this time, this 20N is right at the beginning. And the other ones we had it added on at the end. But see how 20N is not next to any parentheses? It's separated by an addition sign. We're just going to bring that down. I'm going to bring down my addition sign too. This negative 9 is what's being distributed. And this is why we're changing our signs. Because if you didn't change that sign, we wouldn't realize you're distributing a negative 9. So be careful with that. All right, negative 9 times 2n means I have negative 18n. I'm going to bring down my addition sign to separate those terms. And a negative 9 times 4 is negative 36. So step 1, step 2, both done. We keep, change, change. We got rid of our parentheses. Now what we need to do is to combine our like terms. And I see that we have a 20n and a negative 18n. They both have n's. They will hang out. 20n plus negative 18n gives me 2n. All we had to do was add those coefficients. And I still have this plus negative 36. And then we are done. All right, last but not least, I know it looks lengthier than the others, but it's just the same steps. Don't worry about it. All right, I'm looking for subtraction. Here it is. We'll add the opposite. Step 2, I need to get rid of parentheses. This 2 is the only number that's next to parentheses. The others are being added separately, and when that happens, all we do is just bring it down. So I have 10x plus, we need to distribute this 2. So 2 times 3x is 6x. Bring down your addition sign. 2 times 4y is 8y. And I still have that plus negative 4y at the end. All right, we're not entirely done here because we have some like terms that we can combine. We know that x's like to hang out together, right? It's uncomfortable, but they do. So to combine these, all I do is add their coefficients, and we get a 16x. And the y's also will hang out together. They have identical variables. They'll hang out. So 8 plus negative 4 is 4. So I'm left with 16x plus 4y. Don't make the mistake of saying, oh, then I have 20xy. You don't. xy is the light orange rectangle. X's and y's are two separate things. They can't be combined together. They're apple and oranges. You're done. I'll see you tomorrow.